Hello everyone and welcome to our next video on the Doppler effect. This section is a very small section under Doppler effect called the Doppler effect with light. Alright, so although we've applied Doppler effect to sound waves, Doppler effect can also be applied to light waves as well. Alright, so when I'm sure we're all familiar with from grade 11, the electromagnetic spectrum or the color spectrum. If not, it will be introduced in this section. Okay, the color spectrum, a frequency in the color spectrum of light could result in a change of color, all right, which could be visible to the naked eye. So we observe a change of color, whenever we are looking at light, we see, okay, the color changed from blue to green or from to red, purple, blah, blah, blah. All right, there's actually a frequency shift that occurs. Okay, and as I mentioned, it's known as a frequency shift. Now, when we're going to study the Doppler effect with regards to light, all right, we must note a few important things. On the visible light spectrum, we can see that blue light has shorter wavelengths and red light has longer wavelengths. Shorter wavelengths equals higher frequencies. So if we have a short wavelength, we know that, hey, the frequency is going to be higher. Okay, shorter wavelengths. All right, and if we have longer wavelengths, we know that the frequency is going to be lower. All right, so in the middle of the spectrum, we have what's known as green light. Okay, so what I'll do quickly is I'll just draw a quick spectrum over here. So on this side, we'll have blue or blue light. In the middle is known as green light. All right, now in between, here and here and here and here, there's the other colors. All right, other colors. We have maybe purple. We have yellow. All right, we have other colors here, such as those. Okay, and over here we have red light. All right, now we know what happens with blue light. We know it's shorter wavelengths and higher frequency. Okay, so we're going to shorter, wave the length of wave is measured in lambda, shorter lambda. All right, and we know it has higher frequency. When over here in the red light we have longer wavelengths, and I'm going to say longer lambda, all right, and we have lower frequencies. All right, so that's what happens over there with red and blue light. Now, present here within the middle of the green light relative to the spectrum, there are longer wavelengths, as I mentioned, at lower frequency, as it is closer to the red light part of the spectrum. Therefore, shift towards the longer wavelengths are known as red shifts, and shift towards shorter wavelengths are known as blue shifts. All right, let's just have a quick summary of this section quickly because this Doppler effect is now complete. The Doppler effect can be observed in all types of waves, including ultrasound, light, and radio waves as well. If you did not know this piece of wisdom or piece of general knowledge, that sonography makes use of ultrasound and the Doppler effect to determine the direction of blood flow. Alright, now light is emitted by the stars. Alright, due to Doppler effect, the frequency of this light decreases and the stars appear redder than if they were stationary. This is called a red shift and means that the stars are moving away from Earth. This is one of the reasons why we can conclude that the universe is expanding. Alright, so that last point there is extremely important as it does come up in the exam, alright, which we will see a little bit later in the questions. Alright, that due to the Doppler effect, the frequency of the light that is emitted by the stars decreases, alright, as it approaches Earth. Alright, and the stars appear to be redder. In other words, their frequency tends to go more to the red shift. Alright, and it also means that the stars are moving away from Earth. Alright, so the distance between the stars and the Earth are increasing. Okay, therefore lambda is a little bit longer. Alright, and the frequency obviously would be lower of the light, because the light formula, all right, the formula for light is C equals frequency times lambda. All right, that is the formula for light. All right, perfect. This is one of the reasons we can conclude that the universe is expanding. All right, so we know what type of waves that Doppler effect can be used in: ultrasound waves, ultrasound, light waves, and radio waves. Sonography makes use of ultrasound and Doppler effect to determine the direction of blood flow. All right, and the light emitted by the stars due to the Doppler effect, it seems as though the light that's emitted by the stars is decreasing and appears to be redder. It's known as a redshift, and we conclude that the stars are moving away from Earth, resulting in the universe expanding as our reason. I'd just like to take a moment to explain sonography quickly. Okay, back in the summary, we saw that sonography makes use of the ultrasound and the Doppler effect to determine the direction of blood flow in a person's body. All right, so the instrument, okay, that we use with sonography is called the Doppler flow meter, and this Doppler flow meter uses ultrasound or ultrasonic waves transmitted into a person's body in order to determine the blood flow. Now, what happens is the sound waves will be reflected by tissue, bone, and blood, etc., all right, and other arteries in the body, and measured by the flow meter. Now, if the blood flow is being measured in an artery, for example, the moving blood cells will reflect the transmitted wave, and due to the movement of the blood cells, the reflected sound waves will be Doppler shifted to higher frequency if the blood is moving towards the flow meter, and to a lower frequency if the blood is moving away from the flow meter. So it seems as though this is quite a hectic definition, but in fact it's very easy to explain. Okay? When answering a question, what is sonography? Or we can say, to make this a little shorter, right? We can mention that the instrument called the Doppler flow meter transmits ultrasonic waves into a person's body. The sound waves will be reflected by tissue, bone, and blood, and will be measured or recorded on the flow meter. If the blood flow flows towards the Doppler flow meter, all right, it will result in a higher frequency. And if it's flowing away from the Doppler flow meter, all right, the Doppler flow meter will record a lower frequency. All right, perfect. There's a nice summarized version for you, okay, that explains what sonography is, as well as ultrasonic waves as well.